Okay, so we come to the next problem, and it says a graph satisfies this thing. Okay, what is this thing? E is the number of edges and V is the number of vertices in the graph. So the graph satisfies this property. E is less than equal to 3V minus 6. And the min degree of G is defined as min V belongs to capital V degree V. Okay, so basically min degree is the minimum degree that a vertex in that graph can have. Okay, so you have many vertices in the graph, and when you say min degree, what does this mean? Min degree is the degree of the vertex with the least degree. So min degree is the least degree. Okay, it's the least degree present there in the graph. Okay, you have many vertices, different vertices will have different degrees, it's possible, and one of them will have the least degree, and that degree is the min degree, because that's what it comes from this thing what they have written here. And then it says therefore min degree of G cannot be, says min degree of G cannot be. Okay, which of these four option is possibly not the min degree of this graph? All right, so how do we do this problem? Okay, how do we do this problem? So what is given to us is E is less than 3V minus 6. Okay, so what do we know about the relation between total degree, that is sum of all the degrees of all the vertices, and the number of edges? It is 2 times E. This is what we know, and this is a standard theorem. I have also proved this in previous videos, and you can find it anywhere. You can watch my videos also previous. I proved this in one of the problems I did earlier. Okay, and then you have 2E. 2E is less than what? E is less than 3V minus 6, so 2E is less than 2 times of 3V minus 6. So what do you get from here? That your total degree is the sum of the degrees of all the vertices is less than this, will be equal to 6V minus 12. Okay, this is what we know so far. And let's assume that your min degree, okay, the degree of the vertex with the least degree is, let's say it is I don't know, let's say it is M. Okay, so the min degree is M. So what can you say about your total degree from this assumption? What can you say about your total degree? Total degree is the sum of the degrees of all vertices. So you have many vertices, and the vertex that has the least degree has a degree of M. Okay, so that means that every other vertex in that graph will have a degree at least M, because the least is M. Okay, so every other vertex will have at least a degree of M. So if you add all the degrees in that vertex, okay, this total degree that you will get has to be, okay, it has to be, sorry, I just wrote it wrong. This total degree has to be greater than what? This total degree has to be greater than or equal to M times V. M times V. Why? V is the number of vertices. Alright, V is the number of vertices that you have out there. Okay, and the least degree you have is m. That means every vertex in that graph has a degree of at least m. So if you add their degrees, you will get greater than m times v, because everyone has at least one. So total degree will be greater than m times v. And when you relate this with, let's call this relation, this equation 1 and this thing 2, when you relate this with this, what do you get? You get is, what you get is this. You get is mv is less than equal to 6v minus 12. And now you can answer this question, that which of these four cannot be the min degree. Okay, so let's talk about this. Let's talk about d. So if m is 6, okay, let's say if m is 6, suppose, then what do you get? You get 6v is less than equal to 6v minus 12. Okay, or if we take this side, 0 is less than minus 12, which is a, what is this? This is impossible. This is called a contradiction. Okay, so by assuming if m is equal to 6, this was our assumption. Okay, this was our assumption, and this is the relation we got by applying this argument. So based on this assumption, we reached to this argument that 0 is less than minus 12, which is a contradiction. That means our assumption is wrong, and that means the min degree cannot be 6, which means the correct option is D. So this is the correct option.